This tutorial is going to be for the Buck Scientific Model 205 Atomic Absorption Spectrophotometer. The directions that I'm going to be giving you follow pretty much verbatim the directions given in the analytical lab, but this tutorial could be used for anyone who wishes to use this instrument for any purpose. So let's start with the instructions as given in the lab, and before we do that, I want to give you a quick tour of the instrument here. So first, looking at it, over here on the right panel, we have the on-off button here, which is the red button. I'll go ahead and turn the instrument on at this point and let it warm up. And we also have, for example, the wavelength readout here in nanometers. And around the side here, we also have the wavelength adjustment wheel. Also on the right-hand side, we have the slit control, which controls the entrance slit of the monochromator. It can be set for 2 angstroms, 7 angstroms, or 20 angstroms, depending upon what optimization is required for a given lamp. Again, we also have the readout window here, which is where all the pertinent information you will need will be found. And we also have the various buttons and controls we'll be using throughout the experiment. Coming around to the left-hand side of the instrument, we have the lamp housing. So the hollow cathode lamp fits right into that opening there. And we also have control wheels for both horizontal and vertical adjustment and alignment of the lamp. On the front panel, we have the fuel on-off switch, so we can use this to turn the acetylene on and off. And also we have the air control down there as well. And finally, down at the bottom, we have the fuel adjustment knob. We can also tell the fuel and oxidant levels from the meter given here to the right. Toward the center of the instrument, we actually have the slot burner. So you'll see that this is where the flame will be. And we also have the nebulizer assembly underneath it, which you can see here. We also have lines for air and acetylene coming in. And then finally we have both horizontal and vertical adjustments for the slot burner here. Here's the sipper tube, which we'll be using to sip up sample and also distilled water when required. And then we have the drain here, and you'll see that there's a loop down here. And before we ignite the flame, we want to make sure there's liquid in that loop, and indeed there is, so that we don't have a flashback hazard. Alright, to the right here, which you can't see, is the monochromator. That's going to be housed underneath here, which lets us select one specific wavelength or emission line from our hollow cathode lamp. And then to the right of that, over in this vicinity, will be our photomultiplier tube detector. Also, you can't see that. Alright, so now let's go ahead and take a look at our instructions. Alright, so we've already located the instrument. If you don't know, it's found here in FSC 305, which is my research lab. It's over toward the hood. And we want to make sure we have it turned on, which we've already done. That can be done by depressing the red button there. And again, we have an active display, which is good. Now, the next thing that we want to make sure of is that the display is showing the hollow cathode lamp of interest. For the analytical experiment that we're doing, we're going to need a magnesium lamp. And we see here that the instrument has already detected the magnesium lamp here. It also gives some pertinent information about the magnesium lamp. It tells us that we'll be utilizing an analytical wavelength of 285.2 nanometers. And we're going to be using a lamp current of 1 milliamp, which is automatically set. And we're going to be utilizing a slit width of 0.7 nanometers, which is 7 angstroms. So we're going to come back around and be sure that the setting is at the 7 angstrom setting. Now it looks like we're good to go there. Alright, so moving right along here, we're allowing the instrument to warm up. At this point, you will have made a series of magnesium standards, and an unknown would be prepared for you, so those would be ready to go, and I have a set right here that I've prepared. Alright, so also it says that near the instrument we're going to find an acetylene tank. So back around to the side of the hood here is the acetylene tank. We'll go ahead and turn that on, even though we're not going to turn the gas on right away at the instrument, but We just want to make sure here that we have sufficient pressures available. And it looks like we're right around 100 psi on the primary, and we look good on the secondary, so we should be good to go for this experiment. Again, we're not going to turn the acetylene on until we're ready to ignite the flame, and that will be done at the instrument. Alright, so that takes care of the acetylene tank. Now, we also want to make sure that we're showing an active analysis mode, and that's what we're showing on the instrument right now. I know that because I actually see an absorbance here. Now at this point, this absorbance really doesn't mean anything. Alright? Now, we've also noted the specific information about the magnesium hollow cathode lamp that we're using. So next we want to make sure that the analytical wavelength is close to that value. So we see there that our wavelength should be at around 285 nanometers. So I'm going to use the wavelength adjustment wheel to get myself close to that. So I'm going to set my wheel to about 285 nanometers there. We're going to come back and adjust this with fine tuning just a little bit later. Alright. We've also set the monochromator slit width to 7 angstroms, so we know we're good there as well. Now, what we want to do next, according to the instructions, is to optimize the wavelength setting and also to align the lamp. So to do this, we have to find the align button, which is right here, and we're going to press it. And that takes us to a normalized energy bar that we see here. And the idea here is that through lamp adjustment and wavelength adjustment, what we're trying to do is optimize the energy on this bar. So we're going to turn the wavelength knob very slowly until we actually optimize the energy coming through the instrument. So I'm fine-tuning that monochromator so that I'm centered right at that analytical line of 285.2 nanometers. And this looks like it's about right. Okay, the next thing that we want to do is double check on the lamp alignment. So if you recall, we have these alignment wheels on the left panel of the instrument. There's a horizontal adjustment, and around back we have the vertical adjustment. So what I'm going to do is I'm going to watch the normalized energy bar, and I'm going to turn those until I get optimization. And generally I find this adjustment doesn't make a whole lot of difference. Okay, that was the horizontal. Now I'm checking the vertical adjustment. Okay, looks pretty good. So I'm really not going to mess with that. I'm pretty happy with those adjustments as they stand. Okay? Alright, so at this point, the lamp should be properly aligned and we should be centered at our analytical wavelength. So that takes us to item 6. So the next thing we want to do is to align the burner head for optimal results. So remember, we have both a vertical and a horizontal adjustment that we can make here. Now obviously the vertical adjustment is going to move the burner head up and down. The horizontal adjustment will actually move it back and forth inside of the cavity here. Alright, so at this point, let's see, we want to lower the burner position to well below the optical path of the lamp. So I'm going to bring this way down by turning the knob to the left. Now the problem here that we have is that some of these have been stripped, so I need to actually physically move the burner head down once I turn the knob. At this point we should be actually well below the beam path. And I can double check that with, for example, a piece of paper or a card. You probably can't see that very well, but you might see an orange circle there that indicates the output of the hollow cathode lamp. And you can see that I can see the full circle there. Alright? So at this point, what I want to do is I need to go back to the, let's see, I want to make sure I've got this right. I want to go back to the auto 0 here. And this is going to take me back to the absorbance scale again. And that's what I want to look at. So what I'm going to do is I'm going to now raise the burner until I actually break the beam with the burner head itself. And when I do that, I'm going to actually read some absorbance here. So I'm going to move that vertical knob to the right. As you can see there, I'm raising the burner head. And I'm going to continue to do that until I am noting a non-zero absorbance. So up we go, 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 up we go. So I'm just now starting to break the beam with the burner head. So now what I need to do is back this off by about 2 full turns. Okay, so there's 1 turn, there's 2 turns, and I'm going to push this down. Okay, so now the vertical adjustment should be correct. Now at this point, I want to get the horizontal adjustment correct. So what I'm going to do in this case is I'm going to actually start to nebulize some water. So I have some water here in my beaker, and what I'm going to do is I'm going to go on and make sure that my house air is on. It looks like the house air is on, and you can actually see that I have pressure here on the secondary gauge, which is attached to the hood. So all I need to do now is to come down to the air control and turn that on. Now what you're going to notice here is the tiny droplets. You can probably see them here. So what I'm doing is I'm nebulizing my sample here. And what I want to do is actually bring the horizontal adjustment such that I'm optimizing the absorbance here on the output. So I'm going to bring it back a little bit. Again, it's sort of stripped here, so I'm just going to bring it back a little. And notice that I have a small absorbance here. I'm going to bring that horizontal adjustment to the right, which is actually pushing this back until I actually see an optimization. Now I'm starting to get bigger. Up around 0.4, 0.357, 393. That's probably good. So at this point, I've got a good horizontal and vertical adjustment. Another way I can double check that is to turn the air back off, and I can come back to my card here and I can double check that it looks like I am centered with my beam coming straight down the slot burner. It looks like I am. So I think I've got good adjustment here. Alright, so I now have an aligned burner head. Now, the next thing that I need to do is I need to optimize the flow of the mist on the nebulizer, as I just showed you. So what we want to do again is show that we can get the best mist through here that we possibly can. So to do this, I'm going to turn the air back on, and now what I'm going to do is I'm going to take the adjustment valve here, and this actually adjusts the flow of the nebulizer, airflow to the nebulizer. And I'm going to turn it counterclockwise until I actually have bubbles coming back through. So now I've got backflow coming through. And what I want to do is now turn the wheel to the right until, again, I'm seeing an optimal absorbance over here. So this tells me that I've got the most mist that I can possibly get coming through here, which means that I'm going to have the best delivery of sample, nebulized sample coming into the instrument. So this looks like it's about right. And again, you can see the tiny droplets from the nebulizer coming up and through the burner head here. Okay, so it looks like we've got a well-optimized system here. So I'm going to pull that out to keep the air on. So again, my sample sipper is out of the beaker at this point. Alright, so at this point we are actually about ready to prepare to light the flame. So again, I want to double check and make sure that I've got liquid in the sample loop here so that I don't have any flashback risk, and it looks like I've got that. And now what I want to do is double check that my air is on. And my air is on. It's sitting up at around between 5 and 6 units there, which is fine. And now I'm going to turn the fuel on. Okay, so we always turn the air on first, fuel on second, so we don't have a combustible mixture until we're ready to actually light the flame. Alright, so I'm going to turn the fuel on. You can notice now the fuel there, and I'm going to come through and ignite the flame. Okay, so we have a nice flame here. You can see it, and what I want you to note there are the various parts of the flame. It might be a little hard to see, but one thing I want you to notice is right near the bottom of the slot, or the top of the slot burner there, you'll see that sort of whitish blue region. And that's the inner cone where we have the highest number of atomized analyte atoms. Okay, so That's where the action is going to be, as we've learned in class. All right, just to show you the effect, this is a nice hot flame that I've got here, and I can tell by the color of it. I can actually increase and decrease the flow of the acetylene. So I'm increasing the acetylene flow here. And I want you to see what happens to the flame as I do that. Okay, and at some point the flame becomes sort of yellowish and cool. So this is a very inefficient flame here. So I want to bring that acetylene level back by rotating that knob to the right, fuel adjustment knob, until I've got a nice hot flame with a nice inner cone. Okay, and you can see that. That should be about optimal for analysis at this point. All right, so at this point we are actually ready to do some sampling. So I'm going to first aspirate some water through here. And what we're going to notice is that we have a little bit of absorbance here due to the water by itself. So what I want to do is I want to auto zero that. So I can account for that absorbance, basically blank it out by hitting the auto zero key. Okay, and what will happen after a few seconds is the absorbance will go back to zero. Now I'm ready to actually look at a standard. Alright, so what I'm going to do is pull out my 0.01 part per million standard here, which I have. And now what I'm going to do, I've got it setting down here, I'm going to take my sample sipper and I'm going to put it down inside the sample. And I'm going to watch the absorbance. Now notice that the absorbance goes up. Now it's going to vary a little bit, so you kind of need to signal average this in your head. So for this first sample, the 0.01 part per million that I've made, I would probably write down an absorbance of maybe 0.009 for that. Okay? Now, before you move on to your next standard, what you want to make sure that you do is rinse. So we're going to put the sample sipper back into the beaker of distilled water, and we're going to wait for the absorbance reading to come back down to 0 or something very close to that. And if it doesn't do that, we can also hit the auto zero. But we're going to give this a chance to really wash itself out here. So it's slowly working its way back. Okay? And again, if I get a little bit antsy here, all I have to do is go back and hit auto zero here. And we'll be good. We probably have maybe a little bit of something in there that's causing some absorbance. So the important thing to remember here as you move from standard to standard and sample to sample is that you always want to come back and rinse with distilled water between each standard and each sample. So at this point, let's go ahead and talk about how to shut the instrument down. So what we want to make sure of is that we're turning off the fuel first. So I'm going to come back around here and I'm going to turn off the acetylene at the source with the main valve here. And what that's going to do is it's going to bleed all the acetylene out of the lines. And as the acetylene is bled out of the lines, obviously the flame will turn off. And at this point, what I can do is then bring the fuel toggle switch to off. And now I'm going to bring also the air to off. And then the last thing I would do is come back around and I would turn off the house air. And if we want to, we could readjust the wavelength knob, so the next group actually has to come back and fix it. And if you really wanted to get sneaky, you could change the slit control to something else. So again, the next group has to pick that up. And at this point, we're just going to use the button to turn the instrument off. So there's your tutorial for the Buck Scientific 205 atomic absorption spectrophotometer.